Hello, and welcome to the Linux Security Workshop for the CS166 and Full Stack of Brown CTF. So in this video, I'll be going through the most important commands to know for operating on files and managing permissions, and I'll then go over some high-level strategies for how to approach finding vulnerabilities. So Linux is an open source operating system. So although it does have graphical user interfaces for personal computing, primarily it's used for servers and as the operating system for smartphones and Internet of Things devices. Over 95% of web servers and 90% of cloud infrastructure runs on Linux. Android's based on it, and it's dominant in routers, smart home devices, cars, and televisions. So clearly, it's very important that Linux is secure, and not just secure itself, but also secure in how it's administered. Linux security is interesting in that although there are common vulnerabilities, they're highly dependent on the particular implementation. So that means that it's important to have a good understanding of commands available to us that might help us to find vulnerabilities and exploit them. So with that, let's jump right in and show the essential bash commands to know that will help with this process. All right, so let's jump in and look at some of the bash commands that might be useful for the CTF. So we're going to try hack new room now, and this is just like a Linux machine that we're accessing. So the first thing to cover is a command called echo. And this is really quite similar to sort of print statements in most programming languages. So if we do echo hello, it's just going to return hello. This is going to be useful in a bunch of places for example, like debugging output or just printing things that we want to see. Another command that's going to be useful generally is what's known as man. So this is going to show us documentation for whichever command we give it. So if we do man echo, and we're going to see all of the options and the flags we can use for the echo command. And so that's going to be useful, especially since this tutorial is just going to go through sort of the basics of each command. So if you find yourself needing to do something more advanced, then this is the place to go. The next thing to cover, which you may have used previously, is ls. And so ls is just going to list all of the files in the directory we're in now. And so we've got a.txt, script.sh, and this Shiva1 binary. There are two flags, though, that are useful with ls for finding vulnerabilities. The first is -a. And the difference with this -a is that it's going to show all of the hidden files. And so hidden files are ones that start with a dot. A lot of the time, these are the files and the directories that you're going to want to be looking for. The next flag that's interesting is -l. This is going to show a bunch of different information. The first thing it will show is the file permissions. So this is going to show whether they're read, write, and execute permissions for the user first, then the group, and then all other users. So for a.txt, everyone's got read, write, and execute permissions. Whereas for script.sh, only the owner of the file has read, write, and execute permissions. And this is also relevant. This is the user and the group for each particular file. So those are the permissions that you'll be editing. Okay, the next thing to look at is a cat command. So this is going to print out the output of whichever file we give it. So for example, if you want to see what's in a.txt, you can do cat a.txt. And this is just a text file that has hello in it. So that's not too interesting. Something else to cover. Make a new directory, so make dir, and this is going to create a new directory with whichever name we give it. So if we do make dir new dir, and we do ls, we've now got a new directory called new dir. We can enter this directory with cd, and it'll just be empty, and we can exit out with cd ... We can also move files to this directory. So for example, if we want to move a.txt into it, we can move a.txt into new dir. And so if we list the files in the directory now, a.txt will be gone. If we go into new dir, it will be here again. So we can move this out by moving a.txt back into our current home working directory. If we want to make a copy, however, so we want to keep a.txt in our current directory, we also want to move it to new deal. Then what we can do is, instead of move, we can use cp for copy. We can copy a.txt to new deal, and now a.txt will be here, but new deal will also contain a.txt. If we want to delete files, then there's a command for that as well, which is rm for remove. So if we want to remove a file directly, like we want to delete a.txt, we can do rm a.txt. And there's two options that are useful here as well. One is -r, and so this stands for recursive. So if we want to delete a directory and everything inside that directory, we can specify the -r flag. The other is -f, which is going to force delete and so not prompt us for different files as to whether we actually want to delete it. If we do rm-rf new deal, then we'll delete new deal and all of the files within it. If we do that, then new deal is now gone. So next command to cover is touch. The touch creates a new file with the name that we specify. So for example, if we want to create a new text file for b.txt, that will create that for us. b.txt will be empty. But if we want to move something into b.txt, we can use redirects. And so these are sort of the greater than sign and the double greater than sign. So if we use the greater than sign once, then what we can do is say cat a.txt, which will get that hello, which was the content of it. And we can move that into b.txt. So if we now look at what b.txt contains, it's hello. But if we do this again, right, so we've done it twice now, if you look at what b.txt contains, it's still hello. And so if you want to append output to a file, so say every time that we find something interesting in a script, we want to add it to b.txt, then we can just use the greater than sign twice. So this means that when we have a look at what b.txt contains, it will now be hello and hello. So now we've covered some of the basic commands you can use to read and manipulate files and directories. Let's have a look at file execution and permissions. So if we do ls again, we'll recall there was this script.sh file, which potentially we can run. So if we try to do script.sh, then bash will try to interpret this as a bash command. And since it's not a command, it will fail. So if we're in the same directory, we can do /script.sh, which will specify that it's a file, and it will try to execute it. And so it looks like it's just doing the ls command, and then printing out the current directory. And so if we do cat script.sh, we can confirm that's what it's doing. So something that's useful if we're trying to run multiple commands is $ampersand. And so this will run the first command, and if that's successful, then we'll execute the second command. So if we do echo hello, then $ampersand and script.sh, and we'll print hello, and then we'll run this script.sh script that we have. But what $ampersand will also do is if the first command fails, it'll stop executing. So if we type in some gibberish, it's not a real command, and then run script.sh, then it will fail with that first command and stop executing, so we'll never get there. So this is useful in some cases, but sometimes we want to keep executing regardless. So if that's the case, we want to use a semicolon. So if we type in gibberish again, and then we use a semicolon, then it'll fail on the first command, but it'll keep going anyway and run the scripts. So the next thing to cover is sort of the fundamentals of file permissions. So the first thing that's useful here, if we go back to ls-l, is to try to change the user that owns a particular file. So here we see this as other user called Sheba2, and where's Sheba1. So potentially we could try to change the permissions of a.txt, of potentially Sheba1, this file is owned by Sheba2, and set it to ourselves. So the syntax for this is to say that we want to set the user and the group with Sheba, or the Sheba1 file to Sheba1. If we do that, it'll fail because we don't own this file. And generally, this is something that only root users can do. Something that we can do, however, is use chmod. This is a command that you can use to modify the permissions of the files that we have here. So let's try to change permissions of script.sh. So we see here it's got read, write, and execute permissions for the owner of the file, and then no permissions to do anything for any other users. But this seems like a pretty useful script, and so maybe you want to allow all users to execute it, but we don't want them to be able to read or write it. So the syntax for chmod is to first say whose permissions you're editing. So that's U for the owner of the file, G for the group, O for other users, and A for everyone. And then to use either plus or minus to change the permissions each particular type. So let's say we first want to edit all users and give everyone execute permissions. We can do that for script.sh. So now if we do ls-l, then everyone will have execute permissions. But perhaps we want to have that edit like multiple permissions for all users at the same time. So the way that we can do this is with this notation, where we say that for means reading a file, 2 means permission to write to the file, and 1 means permission to execute. And so we can sum these together. We say first for the user, let's say we want the user to be able to read and write, but not execute. So that would be 4 plus 2, that's at 6. And let's say we want everyone else to be able to just execute. And so since execute is 1, we can do 611 for the script. Now if we look at permissions for it, we've got that the owner has read and write permissions, but everyone else only has execute permissions. So this is a very convenient way of setting particularly quite common permission structures. Since we removes execute permissions for ourselves, if we now try to run the script, it'll have permission denied. And so we can also reverse this, so saying give ourselves execute permissions, the group read and write, and others read and write with CS166. We also need to specify .sh. And now we'll have execute permissions, but everyone else will be able to read and write it and not execute it. So that's the basics of sort of file execution and permissions. So let's have a look at some of the more advanced file commands that are likely to be useful in the CTF. So first thing to cover is a command called find. And this is very useful for finding files with specific properties that you care about. So it's much easier than CDing and LSing in every directory. So if we wanted to find every file on the file system, we can do find /. That'll probably be a little bit too much. So let's just look in the home directory. Right, and this will list every file that's in /home. So we've got the things that we had, like a.txt and b.txt, but also the files in the directories we have read permissions for, in Sheba 3 and Sheba 4, and these other directories. So we can also specify which user or group the owner of the file has to be. So what we can do for that is we can do find /home. And let's say we specifically want to have a look at the files that Sheba 2 owns. And we'll have permission denied for a couple of these. We can look through like that. We can also be more targeted with this. So for example, the TMP directory or temp directory is a place where a lot of programs and users put files that they don't want to hold for a very long amount of time. But sometimes it can still be sensitive information or something that we can potentially exploit. So what we might want to do is look in the temp directory specifically for files that the root user is the owner of. If we do that, we see a couple of files. None of them look to be particularly vulnerable, but sometimes things like that are going to be very useful. Now something that's closely related is a command called grep. And so this allows us to find instances of particular string being used in a particular file. So for example, if we wanted to look for instances of the word bin being used in script, we've changed the permissions just now. Let's give permissions for script.sh and do that again. Then it'll read out those files for us. What we can also do is use -n to see which lines it is on. So since this is just a 2-line file, it'll say 1 and 2. But this can be very useful for looking specifically for things like vulnerable practices that users of the file system might be doing. We can also combine this with find to have some very powerful commands. So what we can do is find, say, everything in the file system. And we can use this vertical bar, which is known as piping. And so we get the output of the first command and pipe that as input into the second command. So the output of find every file will be all of the files in the file system. And then we can use grep to search for particular things that we care about. So for example, we might look for password. And it is possible that some users are storing passwords and other sensitive information in secure ways. And so if we do this, it'll find all of the files in the operating system and then search through to see if the word password is in the file name of any of these files. And so we find a whole bunch of files, and immediately we have sort of some targets to work with if we think any of these are interesting. And so really when we do this, this grep argument that we're searching for is a regex query as opposed to just a normal string. And so this allows us to look for sort of particular patterns that we think are interesting. So things like IP addresses, right, which have a predictable number of dots rather than the full string. And so as you can imagine, there's lots of very powerful things we can do with this command. Of course, there are plenty of other bash commands, but the ones I've just described should be enough to get you started in the CTF. Some other commands that might be useful include su, which allows you to switch to the specified user, sudo, which allows you to elevate your permissions to the root user, single ampersand, which lets you run commands in the background, and ln, which creates a link from a source file to a target file. So in terms of finding vulnerabilities, this will be highly dependent on the mistakes made by the administrators and the users of the Linux file system. So it's worth starting with understanding what the file system is, which users there are, and which programs are being run. Programs in particular are helpful because they can elevate your permissions to the owners. So sometimes programs will have particularly dangerous practices, like relying on your path environment variable. And so the path environment variable specifies which directories to search for executable binaries when you're trying to run a command. So all of the commands we've covered are in /bin, but you don't need to type /bin/ls because /bin is already in your path. And so it finds it automatically. So if you can change your path and run a vulnerable program, find a way to change someone else's path variable, or find a directory in the path that you have write permissions for, those are all good ways to craft attacks. More generally, it's possible that users either don't specify their permissions properly, or they might use publicly readable and writable directories like the temp directory, which is illegal on shutdown. But there are also more specific attacks, like time of check to time of use or race conditions. So if there's a legitimate program A that checks the property of a file X, then writes to or executes file X, it might be possible to overwrite this file between the check and the use. So in summary, hopefully you'll find this workshop helpful, and good luck with the CTF.